Alright, we're building a turbo FZR Yamaha. We built a turbo Honda 125 and we went from 12 horsepower to 20 horsepower, and we're doing a cam on that, so we might be able to get that up to 30. But then we got sidetracked because Kyle found an FZR125 that we've already stripped out of the frame, and we're going to cut 2 cylinders off to turn it into a 125, I mean 100cc for our class eligibility rules, and put a turbo on it. We've got a Garrett GT06, which is a tiny little turbo, even smaller than the Chinese turbo on the Honda, but the compressor map and turbo map says that it's going to work perfect for our target power and the capacity of this engine. There's been a few guys that have done the cut down FZRs where they take off these 2 cylinders, but due to the way the turbo manifold works on that turbo, it's a twin. I'm going to try to take off these 2 cylinders is the plan. We'll see if we can do it. But yeah, I mean, these engines are tiny, context of my hand over the top of it, and the turbo's even tinier, so we'll see how that goes. Alright, so we got the motor torn down. We're just playing around with mocking up the turbo. So that's the tiny little turbo there, which I mean is literally ridiculously small. But as this turbo is supposed to go to a 2-cylinder, it's going to work out perfect with an adapter to go onto the 2 cylinders of the FZR engine. Now, the other guys that I've seen that have cut these down to parallel twins, they cut off those 2 cylinders and keep these 2 because the crank drive is basically right there, so it means you can get rid of some dead weight. I've had a look at it. I can delete 1 cylinder worth of crank, but it means I'll just need to keep the crank pin of the 3rd cylinder, which won't be doing anything but rotating mass, but I don't think it's enough to make a problem. And the main reason for it, well, there's 2 actually benefits. One is due to the shape of this turbo. If we put it on these 2 cylinders, it hangs out too far on the engine, it gets too close to the ground, and the inlet basically becomes impossible to put any kind of filter or elbow on it without ground clearance issues. Whereas here I'll be able to literally just put a nice big foam filter on it, maybe with a little shroud to stop debris coming off the front wheel. Dump pipe out the side, easy as. So there's a lot of benefit to it being these 2 cylinders. From amount of work to do as well, there's another little benefit in that the camshafts have this groove right here, and it stops the cams from walking side to side. Now, if we cut that off, then that groove's gone, as well as the slot on the cams. There is sort of cast-in slots here which you could machine out and then weld on, but it's quite a lot of work just to do that. So for me, I think, even though it seems a bit counterintuitive to leave redundant crankshaft basically just as a shaft to drive the main gear, I think there's a lot of benefits to the packaging for this. And one other benefit is we get to keep the electric starter, which most guys ditch, but I think when you're building an engine that's experimental like this and you're going to be mucking around trying to start the thing, it's nice to have a button that you can just push and it goes. So yeah, that's where we're at the moment. I'll pop the cylinder head off and the barrels off and show you the crank. Right, so cylinders and barrels are off and the top case is off. So this leaves us with the crankshaft. So you can see this gear here is what drives the clutch, which usually lives here. We're not going to be using that cylinder or that cylinder, so what I can do is I can cut that off there flush. I can even reduce this gear a little bit because this is just redundant material. I can machine that down, take some weight off. All that goes in the bin. This one here, I'll have to cut the counterweight to rebalance, because normally I could just leave these alone, but if I take that one off, then this here will have a massive imbalance. So easy enough, just it's a matter of cut it off, grind it off, and then these here will be the 2 cylinders that we keep. Now typical, I've bought an engine and it's got one bad rod journal on the crank, and it's the one that I want. But so I've spoken to the engine reconditioners, and getting it ground is only going to be a couple $100, and I've already got a set of 0.25mm oversized bearings on their way, so that's not a biggie. But I do need to wait for him to grind the crank before I can cut this one in half, because once I cut it in half, he'll lose the center to hang on to it. So it's all part of the fun. But yeah, I think like I say, this will have a little bit of additional rotating mass thanks to this redundant web here, but we also will be losing the flywheel on the side plus this large counterbalance here. So I think all in all, it's for me, I think the compromises are worth it, especially for the packaging. Yeah, I think that's about where we're at the moment. So lucky last for today is doing some 3D prototyping. Kyle has this handy dandy 3D printer, so this will be how we adapt the turbo flange onto the cylinder head. So there'll be some counterboard cap screws that bolt into the original head stud locations, and then there's some drilled and tapped holes for the turbo flange to bolt directly to. Now this one here is actually on the wrong side of the cylinder head. We've since decided that we're going to use those two cylinders, so you can see it'll still work. I just need to redraw it because the studs are orientated differently on the two different sides. But this we already tested it on this side in terms of getting the turbo to bolt up to the head, and looks like it's going to work great. So that's an easy solution. When we come to make this, obviously it won't be plastic, but I'll just I'll get some 16mm plate laser cut or plasma cut out, and then I'll get some, these are 16mm deep as well. I'll get these here bosses laser or plasma out, and then just fabricate them together, mill the surfaces flat after fabrication, and that is how simple it will be to adapt the turbo to the cylinder head. One of the big things with turbos, especially on small engines, which we've learnt on the Honda turbo, excuse it, it's all in pieces at the moment, but the reason that turbo is bolted there is I want to get the turbine housing as close to the exhaust as I possibly can. With small engines, you're running with pretty limited exhaust energy, so any length or diameter increase in the exhaust header pipe before it gets to the turbine results in loss of heat and pressure. And that's effectively what turbos are doing, is just recovering the heat energy in the exhaust gases to spin the compressor. So the closer you can keep it, the better, really, especially in these applications. What's interesting is the compressor map between the two turbos. Even though this is a physically bigger turbo, it's a very old and poor design and performs significantly worse than the Garrett GT06. So with this one here, we're up at about 10 psi, but we are right on the ragged edge of its surge, which is because the turbo is a bit too big for the engine. But even if we solve the surge problem, this turbo only supports a pressure ratio of about 2, so we're already getting pretty close to that. If we can get a little bit more airflow through the engine, which we're hoping to achieve with a better cam. Bear in mind, this engine is completely stock untouched. It's got a really poor cam and tiny little valves. It's only a 2-valve engine, so we're about 22 horsepower at this at the moment. I'm hoping when we put the cam in, we might be able to get sort of more 25 to 28ish, because the turbo will be able to work a little bit better in its efficiency range. But yeah, interesting the design differences between turbos over the year and how much better they have got. The last detail of running a turbo engine is throttle bodies. So I have these. These ones here are off a Kawasaki Ninja 300. They are, I believe, a 30mm bore, which is quite big for a small engine, but the standard carb size is 28mm. So given that we were trying to push hopefully the same amount of power out of the 2 cylinders as this thing did factory as a 4-cylinder, I think that that there will be sufficient. To adapt this to the cylinder head, we'll 3D print some TPU inlet manifolds to get everything lined up. Well, the spacing is pretty good straight out of the box. So we do this. The actual spacing of them to the original manifolds is really close. So that's a good start in terms of printing a new inlet manifold. That will go from that and then gently taper as it needs to the throttle bodies. There's a bunch of crap that can be deleted on here. These things have secondary throttle blades and all of this control which will be thrown out. Will mean we'll lose the idle air control, but I don't really care. Reality is this thing will probably, I'll have run high idle anyway for riding. The high revving engines that set are idle at 1500 RPM are horrible when you ride them, enormous amounts of engine braking, so probably end up idling at about 5000 RPM knowing how all of my small bucket engines end up idling. So yeah, once I get some more machine work done, we'll do an update.